is a nuisance at times. It's worse than a nuisance at times, but it's a marvel most of the time. Such an amazing material. So while you measure, be sure to find time to marvel as well. Here we go, measuring snow. Beware, it is more difficult to measure snow than it is to measure rain. You know how easy it is to go out and check that gauge after a rain. You just look through the clear plastic. There's the amount right there. You just read it off, go inside, type it in, you're done. 1 minute, 2 minutes, no problem. Snow takes more time. There's more elements associated with measuring snow, as you'll see momentarily, but it's also very important. The data we collect serves many useful purposes each and every day. What are the tools of the trade? Well, there's our 4-inch diameter, high-capacity CoCoRaHS rain gauge in action with some excellent photographs here in the snow. And we use for winter measurements, you typically bring that inner tube and funnel that we have on during the summer. You bring those in and you just collect the snow in the outer cylinder. If that were not the case, that funnel would plug up right away and we would get very unrepresentative measurements. Another useful tool of the trade is a snow measurement surface, perhaps a piece of plywood, perhaps a flat sheet of plastic, white PVC, white for the purpose of being a reflective material, just like snow itself, so it won't warm up and help prematurely melt the snow. You want it to be light enough that you can move it around, heavy enough that it won't blow around, and a 1/2 to 3/4 inch plywood. Painted white's an ideal surface material. Minimum of 14 by 14 inches. You can use bigger if you want. 16 by 16 is pretty good. 16 by 24, whatever. The exact shape is less important than it's white and easy to work with. You need to have a ruler for measuring the accumulation of snow and the total depth of snow on the ground. You want to be measuring to the nearest 1/10 of an inch. There aren't that many rulers that are marked off in increments of 1/10 of an inch. We got a supply from the Iowa prison industries, heavy-duty rulers that work pretty well, but they cost a modest amount. If you just have an old standard wooden ruler, they work fine. Just remember you have to convert from fractions to tenths. Whole inch and 1/2 inch is easy. 1/2 inch, 0.5. So that would be 3.5. That would be 3.0, 4.0. But when you're at a 1/4 inch, then you have to decide, ooh, is that 3.2 or is that 3.3? Well, if it's just below, it would be 3.2. If it was just above, it was 3.3. That first 1/8, you'd call that a 1/10. That would be 3.1, etc. We also have a table on the website, but convert to tenths. That's the standard way of reporting snow. It's been the way the National Weather Service has reported snow accumulation for well over 100 years. Something to help with a couple different features of snow measurement, which I'll demonstrate momentarily, but a spatula or snow swatter, a flat surface that's lightweight that you can take out with you, that'll help you with a couple of features that I'll show momentarily. Very useful to have. So those are the tools. It doesn't take much to do the observations, and it does take the heart and the enthusiasm to go out on a cold, dark morning. And by the way, I will make the point of reminding those of us who perhaps aren't so steady on our feet, and that could be all of us on some icy mornings, that we want you to be safe. You don't have to do these observations. These are observations that you want to or get to, depending on your point of view, but you don't have to. And if you're putting yourself at risk going out on a very icy, very cold or windy morning, wait. Stay inside. It can wait another day. No, we won't get the great data that are helpful, but we'd rather that you be safe. So be careful when it's really slippery and icy. Do not put yourself at risk. Okay, so you have to know where you want to measure, and you've already made the effort of finding a place to put your rain gauge. Once you find an open spot for your gauge, sometimes the best place to measure snow is near that gauge. Sometimes it's not, depending on if you have particularly windswept areas, you're going to want a protected area still in the open, but where you get more uniform snow accumulation that's representative of what's falling in the open. But the open, again, is more prone to drifting and redistribution. So you need to figure out a representative area and then place your snowboard in a good place to find it. We suggest, again, go back to that picture. You know exactly where that snowboard is when it's grass. You don't know where that snowboard is when you've just had 8, 10, 12, 20 inches of fresh snow. We suggest marking the location of your snowboard with a ruler, or not a ruler, with a flag, something else that will perhaps help you find it on this surprise snowy morning. Again, when snow is anticipated, that funnel and inner tube are not going to be helpful. They need to be indoors where you're going to be melting the snow. Bring them in, have them where you know where they are, because you'll need them during the melting process, but you don't need them when it comes to collecting snow in the gauge. Let's do the measurements. Here comes snow showtime. 4 fundamental measurements that we're striving to obtain. You're measuring the accumulation, the depth of that new snow, and we refer to new snow as snowfall, the amount that's fallen in the previous 24 hours. Then we want to get a water content of that snow, and that can come either from your gauge or from a core sample on your snowboard or a more representative location, because sometimes your snowboard also gets blown clear or drifted on. But we're talking about the importance of getting the liquid water content of the new snow, plus in the gauge any rain or other frozen precipitation that may have fallen. Then we want the total depth of snow on ground, which includes both new and old snow. And on days when you've had no fresh snow, we still value measurements of the depth of the old snow on the ground at your observation time. And then the final observation, and it's optional but heavily desirable, as you'll see from some of the ways our data are used, and that's to take a water content of that total snow on ground. The icy, long-lasting, depending on what country or what part of the country you're in, snow that may require a little more heroics to get a core sample of that icy, older snow. So there's our elements: total snow, your fresh snow, your total snow, your water content of the new snow, your water content of the total snow. Any questions, Noah, before we get going on into the details of each of these 4 basic measurements?
No, Nolan, no questions at this moment. We do encourage folks to type in questions, though, as they come up, and we will either answer them directly or bring them up to you right afterwards. So continue on, Nolan, and we'll stop at the next question time, and I'm sure at that point there will be a couple of questions coming up.
Great. So first of all, it's the new snow. It's measuring that new snow that's fallen and accumulated in the last 24 hours. We call that snowfall. This is a depth measurement, again, in inches and tenths of an inch of the accumulation of new snow. Snowfall is the accumulation of new snow in the past 24 hours prior to melting or settling. So if the snow fell overnight just before your morning observation time, most of us have morning observation times, then what you find on your board or in your yard at that time will be that new snowfall. But if it fell yesterday morning or yesterday afternoon, it will have had a chance to perhaps melt, perhaps settle. What you're trying to do is capture the amount that was there, that depth, prior to melting or settling. And that may require having measured during the day and not waiting just till your 7 o'clock or your standard observation time. I want to advise you, this is as good a time as any. I want to overcome to some degree the old 10-to-1 adage that 10 inches of snow will yield 1 inch of water. It's not a bad first estimate, especially for areas that predominantly get wet snow. Here in Colorado, we predominantly get dry snow, at least in midwinter, and 10 to 1 is often far from the actual ratio that we see, but that's part of why we're doing the measurements of both the snowfall and its water content, so we can see for ourselves what this ratio of snow to water is. There are many factors that affect that, including the type of crystal, the shapes of the crystal, the airspace between the crystalline structure, whether or not there was wind, the temperatures, of course, and the temperatures of the ground where the snow lands. We'll see wet snows that are denser than 10 to 1, sometimes much denser, 8 to 1. We've seen 5 to 1 ratio. Some of you that get sleet have probably seen 3 to 1, maybe even 2 to 1 ratios. But you'll also see the light, fluffy, powdery snows, maybe 20 to 1, maybe a 30 to 1 ratio, and for small amounts of maybe up to 3, 4, 5 inches of snow, we've seen ratios over 50 inches of snow per inch water at those ratios. When to measure? Well, again, because we're trying to capture the max accumulation prior to settling, you may not want to wait until your 7 o'clock observation time to get that accumulation of new snow. You may want to measure as soon as the snow ends, or even while it's still snowing, but while it's getting lighter and you start to notice that perhaps melting is taking place already or settling is beginning to occur, go out and take an early measurement. And then go back and measure later, and then you'll see its dynamic behavior, and you'll watch it as it decreases over time after the snow ends. And it will decrease with time even without melting occurring, just by settling processes. One thing that we've noticed is some very well-meaning observers, thrilled with their snow gauge, will go out and attempt to measure the accumulation of new snow inside their gauge. And I will tell you from experience, the snow will stick to the side of the gauge will hold the snow up, or if there's wind, the snow will not land in the gauge. The place to be measuring the accumulation of new snow is on a snow measurement surface, such as your snowboard, such as a protected picnic table, and perhaps even a deck if you can get far enough from your house to be undisturbed by the presence of your house. But don't measure the new snowfall within your gauge. That's not going to be the same as what's on the ground about 85% of the time. I want to show you why you may want to measure more often than just waiting till your standard observation time. This is just an example of a day where you do your observation. Let me get my cursor. There we are. It's 7 o'clock on Monday morning. You report nothing. You've had no precipitation, no snowfall. But it's clouding up, looking threatening, and not too long later, about 9 a.m., snow begins, and it snows for a few hours. Very nice. The snow ends. And at that point, you were available to go out and do a measurement, and you found 2.4 inches of snow on the ground. You're not sure the snow is over. It looks like it is. You're not sure, but sure enough, the sun comes out, the sky's clear, and alas, it's not long before some melting and settling occur. So by later in the afternoon, when the sun sets, we're down to 1.2 inches. Now, fortunately, no more melting or settling occur overnight. Sometimes you will have melting and settling overnight, but not nearly like you do during the day. By the next morning, there's only 1.2 inches of snow left on your snowboard. So what do you report as your snowfall? If you were home, if you were available, or if you had others who were able to notice this, the amount we really want reported is the maximum accumulation prior to melting and settling. That would be the 2.4. Now, if you were out of town, if you were gone at work, if you were gone at school, you may not have had that opportunity, at which time you may only find this 1.2. That may be what you report. But the ideal is to capture what you found prior to melting and settling. So if you report when the snow fell and the sun came out later, we may be able to imply from your observation and your snow water equivalent that that was probably after it melted and settled. So that's a piece of information worth keeping in mind. The dynamic nature of snow makes it to our advantage to measure prior to melting and settling, to report that as our fresh snowfall. But you don't want to be out clearing your snowboard every few hours. You want to wait for it to accumulate and then get your measurement, and don't clear that snowboard more than once every 6 hours at the very maximum, and it's fine to just leave it out all day and just do the single measurement. Where you measure matters. You want to be in a convenient, easy to access, level location that's not prone to drifting and is not prone to premature melting, such what you might see on a south-facing slope or the south side of your house. You want to measure ideally on a snowboard or some other consistent surface, and the procedure for measuring is pretty straightforward, sticking the ruler down into the ground, down to the snow measurement surface, and then measuring to the nearest 1/10 of an inch as best you can. And then when your observation is over, then you clean your snowboard and reposition it on the top of the snow, which we'll show you in some slides here momentarily. So that's the sequence. If you don't have a representative location, or if it's one of those storms where it has just drifted everywhere, then you're likely going to have to take a little bit of a stroll and do an average of multiple measurements to try to determine what is your best estimate. Sometimes that's all you can do, is a best estimate of the average snowfall that has occurred in the last 24 hours. Be careful. You don't want to measure for particularly wet snows or snows that fell with very little wind. Don't measure under a tree, because you'll see on these branches that tree is intercepting quite a bit of snow. Under that tree you find 3.0 inches in this particular example. But walk it 20 feet away, out from under the snow, under the tree I mean, and there's 6.5 inches. That's most likely the better measurement, almost certainly the better measurement in this situation. I want to alert yourself that you may have to bend over or use some other technique to make sure you're measuring the amount. I've been spotted, people thinking I'm falling down in the snow with my face in the snow. No, I'm just trying to get a good reading. But if your knees are stiff, and mine sometimes are, then I just take my thumb and forefinger, slide it down the ruler until they just touch the snow surface, and then I can usually estimate to within 1/10 of an inch what that snow depth is. Be careful not to measure just on undisturbed grass without being careful, because the snow will often sit up on top of that grass, whereas your ruler will stick down through the grass. You may be measuring 1 or 2 inches of grass thickness before you get to your snow. So if you're suspicious of that, sort of clear it out, and you can see where the snow accumulation on the grass begins. Measure only that amount of accumulation, not the depth of grass with no snow in it. And again, after you've found your snowboard, done your measurement, perhaps done a core sample off of your snowboard to get a water content there, which we'll show momentarily, then you reposition your cleared snowboard on the snow measurement, back on the surface of the snow, reposition your flag so you can find it again, and then you're ready for your next day's accumulation. That's a beautiful fresh snow, by the way. I wish it was snowing here today. It's not. What do you do now that you've got your measurement, 6.5, you're pretty confident that's the amount that's fallen in the past 24 hours. Where do you submit that information on the report form? Well, I just want to familiarize yourself with the precipitation report. Your station number and name automatically appear. You don't have to type them in. The date automatically appears for today's date. So as long as you're reporting on the day that you measured, the date will already appear, as will your time of observation, or at least your default standard time of observation, the time that you reported to us that you want to do your daily obs. I will suggest that if you have been delayed or have to do it at an earlier time, you're always welcome to type in that box the actual time that you've taken your observations. That's really important information. We want to know it. If you did it at 6:30, even though you're normally scheduled for 7, go ahead, type in 6:30. Important information. Here is where that snow amount goes. It's here in the block that says new snowfall, 6.5. You type that in. When you find your form unpopulated with data, it will say NA, which means not available. But no, your measurement is available. 6.5 inches, just type that over the NA, replace the NA with 6.5. That's your accumulation of new snow in inches to the nearest 10th inch. Good job. One item, this is particularly for beginners, there's this temptation, you're all excited with your first snow measurement, there's the temptation to type it right into that first box, the rain and melted snow, the amount that you've reported your rain in every time before this. No, that's not where the 6.5 goes. That goes down there. 6.5 inches of water would be huge. 6.5 inches of snow, a nice snow. So that's reserved for the water content, as you'll see momentarily. So this is a time to ask questions or take questions. Noah's got any questions I could answer at this point?
Hi, Nolan. Yeah, actually, we've received quite a few questions of coming in, and just to let anyone know, we are doing our best to answer your questions live in the background. So either Zach or Henry or myself are answering some questions, and we've reserved a couple of them for you, Nolan. Specifically, a couple questions came in regarding settling, snow settling. One question was basically, how do I know if the snow is settling? Is there a way to tell that the snow settled if you were gone?
With experience, yes. If you don't have experience, it's a little hard to tell. The water content is always a good way to tell, and your own time spent experiencing snow. It's the low-density, fluffy snows that fall with light winds and cold temperatures that are particularly prone to settling. Very wet snows, especially ones that fell with fairly small snow crystals, are not so prone to settling, although those same ones may be prone to melting especially if there was some warm ground beneath them. So there may be some settling occurring because there's melting occurring beneath. So it's those situations when you've had a very low density snow, or it occurred shortly after 7 a.m. the previous day, so that it's been on the ground for nearly 24 hours. That has a good chance of settling. Likewise, if the sun came out after the snow fell, that is a factor that greatly hastens settling because it changes the crystal structure as there's solar absorption on that snow surface. Those are some of the factors to look for.
Great, thanks, Nolan. And to follow up with that as well, kind of piggybacking on the same notion, you mentioned in that slide how if you're gone and you weren't there to notice the settling, and so the next morning you would report that I think it was 1.2 in that example. The question is, if it's best to, if we really want the 2.4 from the point where it was at its maximum, what good does it do to submit what you found the next morning?
Well, this is why we love having multiple observers over fairly short areas, why we really have a goal of 1 observer per square mile in urban areas and 1 per 36 square miles in rural areas. We will be able to tell by looking at the data and by the comments that you make. We'll be able to tell who measured prior to settling and who measured after. And those two pieces of information together are very valuable. So most observers don't have the luxury of being home all the time to be able to capture it prior to melting and settling. We really don't expect everybody to do that just by practical limitations, but it is the fundamental observation. The reason why we strive for that is the National Weather Service historic first-order stations, the major city stations of the country, they had the luxury of having human observers on duty 24 hours of the day, and they were able to capture that. That's meant much of our historic data at major cities was measured in a way that captured the max accumulation prior to melting. That's the desire of the cooperative network of the National Weather Service, other than CoCoRaHS, the largest source of historic precipitation data in the country dating back over 100 years. CoCoRaHS is trying to capture the best quality data we can, and it's going to be a combination of those that only have time to measure the once a day at the time of observation, but it'll be others that have the luxury of measuring more frequently and having a better chance of capturing that measurement that will make it more like the historic data from our first order stations.
Great. Thanks, Nolan. Those were some great questions, and we'll let you continue on. The other questions so far that have come in are going to be covered shortly. So thanks, and continue on.
Very good. All right, now we're getting into the very important water content of the snow. And why do we measure water content? Well, that's one of the big reasons that snow is so important. Its depth of snow is something we like to talk about. Its water content is where much of its significance comes. The water that is available to go into the ground, the weight of the snow that may affect how roofs are designed, and how buildings are built, how much effort it takes, how much energy it takes to shovel snow is a function of its water content, not just its depth. So we need to measure its water content, and let's proceed with those details. Oh my, is that a beautiful morning. This is what you may be encountering some days this winter. I know most of you haven't had a lot of snow yet. Some areas had some early snows, and now there hasn't been much recently, but let's get the measurement. Getting the water content, first of all, of what ended up in the gauge. That will be the first basic measurement. And this is an important one because much of the country receives mixed precipitation. It may start as rain, change to snow, change to freezing rain, change back to rain. So what's in your gauge may be a combination of different forms of precipitation. Unless you measure what's in your gauge, you may not get the full amount of precipitation. So let's start with the gauge amount. First of all, you have to retrieve your gauge and get a clean sample of what's in the gauge, and some mornings you will find snow on the rim of the gauge. What are you going to do with this? Well, that's where your snow swatter or spatula comes in handy. You're going to try to make an objective determination of what belongs in that gauge and what belongs outside. You know your outer cylinder, it's got a beveled edge, and really only that which fell within that 4-inch inner circle is what belongs in the gauge. The snow that collects on the rim outside of that beveled edge does not belong in your gauge sample. So you follow the following procedure. You take your snow measurement surface, push it straight down on that top rim of the gauge, and make an arbitrary but objective determination of what belongs in and what belongs out. And then that which is out, what's collected there on the top of that post, that doesn't belong in your gauge sample. Brush it away. You now have a reasonable gauge catch to take your water content measurement from. Your next little challenge will be removing the gauge from its mounting bracket. I keep one gauge not on a mounting bracket just so I don't have the problem of it getting frozen in place. You may have to have a little bit of warm water with you or have lubricated the bracket so that you can slide that gauge in and out of the bracket easily even when there may be ice present. So that's something you may have to deal with. Once you've retrieved your cylinder, bring it inside if you're close to, if your home or office is close to where your gauge is, bring it inside, and you're now going to do, I'm going to show my recommended way of melting the snow. We know that there are those who have some other methods. Some of it includes use of microwaves. You have to be careful with microwaves. We've had observers send us beautiful pictures of nicely distorted, misshapen gauges where they overheated their gauge in the microwave. Oh dear. Try not to do that. But some of use some gentle techniques that work, but be careful. I suggest the following, the warm water technique. And the way you do that is you first pour warm water into the inner cylinder, and based on how much snow is in your gauge, for small amounts of snow you only need small amounts of warm water, but for large amounts of snow, especially heavy wet snows, you may need large amounts of water. And here's a very important trick. You have to know how much warm water you poured in there. If you want to have an odd feeling experience, get a beautiful snow sample in your gauge, come in, pour some warm water into it to melt it, and then realize, oh no, I have no idea how much I just poured in there. So make sure you note the amount that you're pouring in. In fact, good idea to write down that amount so you don't forget it while you get involved in all the rest of the observation. Then you pour it into your snow sample. You swish it around a little bit to make sure that the sample is totally melted, and then you do pouring it back using your funnel and inner cylinder, pour it back into the calibrated inner cylinder, making sure you don't spill it over the top. If you've had a really big snow, it may take more than an inch of warm water, or it may take an inch of warm water to melt it, and then you may have almost 2 inches of total sample. So make sure you have a plan to not spill, and then you read the total of the amount you added plus the amount that was in the gauge that is now melted. You have your total. You subtract the amount that you added from the total. You added, in this example, you added a ½ an inch, or let me say, yes, you added a ½ an inch. Your total was 79 hundredths. You subtract out the amount you added, you end up with 0.29 as your final reading. Voila, that you've accomplished a gauge precipitation amount. Now, sometimes what's in that gauge, and you're going to be the one to best judge this, and sometimes the best way to judge it is just independently take a core sample off your snowboard, if that snowboard was a representative accumulation of the new snow in the past 24 hours. Get a core sample, I'm going to show you how, and get its water content, and then by comparing what you found in your gauge to what you found on a core sample, you'll be able to, number one, make some interesting observations of the issues of observing snow and its water content, and then you'll be able to determine what you're going to actually report on your form. So here's how we get a sample off of a snowboard for a core of new snow. Your snowboard is your first choice of where you want to make that measurement. You take a core by pushing your gauge upside down onto that snow board, right down to the surface, and then clearly pulling it off. If you have observed an average of 4 inches as your new snowfall, but your snowboard did not have 4 inches on it, then you may have to take a little stroll and find an area where the new snow is close to that 4-inch amount that you think is the better measurement, and then take your core sample there. Here you go. You pop that your gauge upside down into the snow. You slide your snow swatter or spatula or other thin device under it so the snow doesn't fall out. You lift it up, and then you proceed just as you did with your gauge to get a water content measurement. The same melting and measuring technique. By the way, at the end of this presentation, I will show how you might use the weighing technique. If you're in areas that measure snow a lot, you may want to be using a scale to measure the snow. It makes the observation much quicker if you have a good kitchen scale, but we'll talk about that later. And then, when you have your two measurements, you melt it, you got your core, you have your gauge. Maybe the amounts were different. In this case, you got 0.29 inches in your gauge, but when you did the core sample, you found 0.59, much more in the core. And you say, whoa, my gauge must have missed something. at which time you make an arbitrary, well, not an arbitrary, you make a good judgment decision that says, I think that what I got in my core was a better measurement of the actual water content of the precip from the past 24 hours. I'm going to enter that amount in my rain and melted snow. I'm going to put that same amount, 0.59, in the melted value from core of your new snow amount, and then you're going to put in your comments the water content of the gauge. Precipitation is amount from snow core. Poor gauge catch, not representative of what fell. Amount melted from gauge was 0.29 inches. So we still have the information, because that's important to know, because others in your community may not have done the core sample, and we may see some unrepresentatively low gauge catch values. But that's how you handle your water content from gauge and core. I think it's a good time to take questions again, Noah. Any new questions about this part of the measurement?
No, Nolan, at this point, no questions came in regarding that exact section. Again, we had a couple more questions come in, but you're going to be going over those shortly, so just no need to ask you at this point.
Okay.
And keep on going. Thanks.
I'll proceed with the next section then, which is the measurement of total depth of snow on ground. And that will be what's left of the new snow plus the depth of the old snow and ice that may be on the ground at the time of the normal time of your observation. So now we got to go find a good place to get the total depth of snow on ground. That may not be right where your gauge and your snowboard are, and this requires more of a visual assessment of how that snow has been settling and aging over time. And again, I want to repeat that it's a measurement that you'll take on days even when there's no new snow that's fallen. We still want to know the depth of old snow on the ground and watch how that changes over time, because that too is dynamic and tells a lot of things about snow. Snow depth is the average depth of snow, including old snow and including ice layers, as well as any new snow on the ground that remains on the ground at your normal observation time. The challenge of old snow, even more so than new snow, is sometimes the fact that it's even more ununiform in terms of its depth over the area of your yard and over your neighborhoods. It may require taking several measurements and getting an average. And you're going to have to make sure your ruler gets through all the layers of snow and ice right down to the bottom. And sometimes there's some pretty stubborn layers, which is why we recommend very firm rulers, perhaps metal ones that can slice down through ice. And then, unlike snowfall that we measure to the nearest tenth, we know your measurements of total depth are likely going to be a little bit more approximate, and they're going to be averages of multiple measurements. So you really only need to record them to the nearest half inch if you can, or whole inch if you think that's more appropriate, to get your best judgment of the average depth of snow remaining on the ground at your time of observation. You want to avoid artificial accumulations. That would be plowed snow along the streets or sidewalks, the largest, most unrepresentative large drifts, or shoveled snow. That doesn't count. Beware, and you've probably remembered situations like this where some areas melt out quicker than others. The south sides of structures, south-facing slopes, areas under trees, not the shaded areas behind trees. So it's going to require an average, and that will include an average of the bare areas as well. So a good simple example is, let's say that half of the ground is snow-covered, half is bare. The snow-covered areas average 2 inches, but that's only 50% of the ground. The other part is bare, and you end up with the appropriate report for that situation is a spatial average of 1.0 inches, and that's what you would report as your average depth of snow on ground in that sort of situation. As soon as the bare ground is dominant. More than half of the natural areas. You don't count streets in that average because they are cleared earlier. But of natural areas, when half or more, well, let me say that again. When more than half of natural areas are now bare, you report trace and mention the range of any remaining depths in your comments. So you may have a situation where the majority of the ground is bare, but you still have 8 inches of snow in the shade of your house on the north side. That's worth mentioning in your comments, so we can describe that situation. In fact, I tend to put a percentage of ground that is snow covered, and with my report, even though it's visual, it's approximate, I may be off by 10%, but at least it gives the right idea. And if possible, report that total snow depth every day that there is snow on the ground. We love watching it, not just when that fresh snow falls, but also watching as that snow departs through this process of settling and melting. Where do you report the total depth? That's the bottom block there. The new snowfall and its water content were there. Here is where the total depth of snow to the nearest half inch or whole inch goes. If you can get to the nearest half inch, great. If you're not confident with your estimate, go with the nearest whole inch, and that's just fine. Questions about total depth of snow on ground before we go to our final section on snow water equivalent?
Nope, Nolan, no further questions on that section either. I think we just do want to remind folks, though, that the data entry page defaults on many of those to NA, and so don't feel obligated to do every single report every day. We appreciate the more that you do, but to keep in mind that those extra reports are optional.
And we know that those of us who have to get to the office in the morning, you may not have the time to do all those observations every day, but we appreciate each and every good observation that we get. All right, finally, what we call SWE, and you'll hear us talk about SWE. It's sort of a magical term in the hydrology world because the water content of snow is a huge source of water for many of our nation's rivers. Anybody who lives near the Missouri River would know that this year, where we had huge flooding flows for literally months from the melting of snow from the northern plains and the northern Rockies. But SWE, snow water equivalent, is important anywhere in the country. Here we are, the water content of the total snow on ground. That may be something that fell weeks or even months ago in the northern latitudes, but we still want to watch that progression of snow water content because it's going to be important when it melts. In the parts of the country where snow is on the ground, most of the time in winter, or at least for prolonged periods of time, it is not necessary to try to make a measurement of the total water content of the snow on ground every day. What we recommend is for those areas where snow is a more regular visitor and lasts longer, to do the measurements on Mondays. And in fact, you can even go out and get your core sample of the total depth of snow on the ground, get that water content core sample already Sunday afternoon or evening. You can bring it in, maybe let it melt naturally so that by the time you do your observation on Monday morning, it'll be all ready. You just have to do the measurement and send in the report and not have to take a new core. That's if you're not having melting or additional precipitation Sunday night into Monday morning. Provides an estimate of how much water is in that snow that's on the ground that could affect water for agriculture, water for rivers and streams, water for any of a number of important purposes. Very useful. When it gets really deep, when it's more than a foot or two deep, the process of getting a Monday morning snow core could be arduous. I don't want you to have to go through heroics. You can even you may not want to use your regular 4-inch outer cylinder, especially if the snow is icy, because it could damage your gauge. we suggest a 4-inch diameter stovepipe or a 4-inch diameter heavy PVC, perhaps beveled, in fact ideally beveled, and ideally made some irregularities into that edge so you can sort of use it to cut through ice layers down to the snow surface. If you get so that you've got to come up with a little dirt or a little grass at the bottom, that tells you you've gone all the way and you've got a great core. So again, some parts of the country takes more work than others. Most areas of the country don't spend a lot of time with more than 10 to 15 inches of snow on the ground, and then you can use the regular outer cylinder of our gauge to get that core sample. So to get the measurement of SWE, snow water equivalent, you're going to take a snow core, you're going to melt the core sample, and you're going to measure that snow water amount. Your first responsibility is to find a representative location, and so if you've done your total depth of snow measurement, you'll know what you are going to report as your total depth. Then you want to find a place to take your core sample where the snow is that depth. So in this case, we're reporting a 7-inch. 7.0 is our total depth, so we want to go find a place where the snow is 7 inches deep. That's where we're going to take a core, and that's what we're doing right here. In this case, it's likely not on a snowboard. It may not be on a standard snow measurement surface. It may just be on the ground. That's okay as long as you can get a nice clean core. You get the core, you slide something under it. In many circumstances, you lift it up, you flip it over, you've got your core sample. In wet snows or in some situations, it just works out magically where you push the gauge down, you twist it, you tilt it a little bit, you pull it up, and voila, a perfect sample comes right out. I have this happen a few times every year, but not all the time. So many times I need to be sliding something under it to get a clean core. So now I've got my core sample. You just go through the same procedures as before, melting and measuring to get its water content. Last year, and I want to thank those of you who may be on the webinar today that were in the many parts of the country that carried deep snow for week after week after week. We had core samples coming in with 3-inch water content, 4, 5, 6, 7, 8, some of them over 10 inches of water content. We knew there was going to be flooding. We knew there was, or at least a high risk of that, and we knew it because of the dedicated service of many of our observers who were going out there to get those measurements. Again, I will encourage you to, if you're in those sorts of parts of the country, to consider weighing snow as a much quicker way than having to melt that much water content. But we'll talk about that later. Where do you report your snow water equivalent? It's right there, the bottom of the block. Again, it will normally fill in with an NA. That'll be the default value, but if you've done a core sample and gotten a water content of the total depth of snow on the ground, that's where it goes. In this case, the value was 0.63 inches. Any questions about that before we end up with our series of special situations?
No, Nolan, no further questions at this point. I do want to remind you we've got about 5 minutes to go before we reach the top of the hour. We will, of course, stay longer if people have questions afterwards, but just wanted to give you that time update for just your knowledge. So continue on, and we'll finish up the webinar with these last couple of sections.
Thank you very much. And any of you who live in most areas of the country that get snow know that there are many times when it's not just a straight, quiet, uniform snow situation. Often there's wind, or there's rain, or there's sleet, or there's freezing rain, or there's old layers where you're not sure where the old and the new snow differ. There are many situations, and that's where judgment and experience come in, but I'm going to give you a few situations here that will help you to know at least standard way approaches to some of the common special situations. When it comes to wind, that's where averaging comes into place. What lands in your gauge with wind-driven snow is likely not what landed on the ground. You will watch snow, wind-driven snow, be deflected around your gauge, up and over your gauge, all sorts of things. So your gauge may not be representative. We've seen situations where people reported 10 inches of snow and had almost no snow end up in their gauge. That would be in the true blizzard type situation. But this is where averaging and core sample taking becomes particularly important. But once you've retrieved what you think is your best estimate of a representative sample, and don't throw your hands up in total dismay. This, with good judgment and experience, even extreme blizzards, you can make a useful estimate, and a useful estimate accompanied by some good comments that describe what your situation was and what the challenges you were facing will give us a whole lot more information than somebody who just left everything NA and said, blizzard, I have no idea. Because you have an idea that you at least had a blizzard and what sort of distribution patterns you had. We don't know that. You can give us your best guess and it will be worth something. Here's some more additional situations. Oh, important. Very heavy snow has just begun or has been falling for a while. You don't have to wait till the next morning to submit a useful report. Remember, we have that additional report over in the upper left-hand corner. When you've clicked My Data, it brings up the default is your daily precipitation form, but then there's other options, and one of the options is the significant weather report. You can use that at any time, and the report will go immediately to the National Weather Service as a real-time report. You can report when heavy rain is falling. Here's what the report form looks like. It populates again with your station number and station name, and it will populate with the current date. But you have to put in the time that your observation was taken. In this case, you didn't have time to measure the water content. Don't worry about it. Just report. I've had 2.1 inches of snow has fallen during the past 60 minutes. You put in the duration, you put in the snowfall, you put in the total depth if you want to know that information. And sometimes just putting in comments, even if you don't fill out anything else, can be extremely useful. Again, you hit the submit button, and within seconds that will be directed to your local National Weather Service office. It actually sends a little alarm to their workstation where the forecasters on duty will see those reports. Very, very helpful. So consider that when you're having not just run-of-the-mill data that they may already have, but when you're having heavy snow, phase change of precipitation, freezing rain, any of those sorts of things, important information. All right, what if the snow melts as it lands? And we see that in almost any part of the country at some time of the year, where it's snowing, but it's not accumulating. If it is melting on contact with all the surfaces of the ground, including grass, you are going to report trace of snow, even if it snowed heavily, as long as it didn't accumulate, as it melted on contact and there was never enough to make the ground white, you're going to report a trace. But if there was enough to make the ground white, that's usually 1/10 of an inch or more. So even though if it melts quickly after it first whitened the ground, you would still be reporting at least 1/10 of an inch if the ground turned white. If not, you're going to report a trace. What if I take my snow measurement but don't have time to melt the core on my way out the door to work or wherever obligations you have? Well, you can go ahead and submit your amount of new snow and total depth, and then leave the precip and the core values with the default values of NA. Well, in the case of precipitation, the default is 0. You're going to have to type in an NA there. Then when you come home and have more time, then you can go back in, edit your report with the water content measurement. So you can get the snowfall in a timely basis. Then you can enter the melted amount from your core or gauge later if that works better for your schedule. Oh, here's a fun one. When you get, this happens especially in the spring or in the fall with some lake effect snow showers and things like that, where the snow comes down but then stops and the sun comes out and the snow melts. And then it snows again. How do you handle with snow showers that are intermittent with time between them for the snow to melt? We're going to show this one example. You go out after an intense snow shower, you find you've had 2 inches of snow accumulate. Oh man, then it melts and it's gone. Oh, another snow shower's coming in. The next one dumps 1.5 inches. Then it's gone. The sun is out, the snow's gone. Whoa, one last snow shower before sunset, 1.0 inches. How do you handle this situation? Well, this last one may be the only one that stayed on the ground, and that may be what people who weren't home to see it have to report. But if you were home to see it and could report it, you would actually report the sum of 3 separate accumulating snow showers as your new snow amount, your snowfall amount. But you would want to mention that in your reports. If you did not have the luxury of being home, if all you experienced was that 1 inch amount, then you would report that as your snowfall, but you would be reporting comments saying, additional snow showers yesterday afternoon melted before I had a chance to measure. Something like that. You have to believe your comments do make a difference and help us truly interpret what your reports are. How do I measure freezing rain? We've not gotten into that, but we have a whole additional section on our training slideshows on freezing rain. But I want to tell you, freezing rain does not count as snow. Freezing rain is precipitation that fell as rain. You will measure its water content in your gauge. You're going to have to, number 1, get it off the mounting bracket, then number 2, melt its water content. I didn't mention this earlier. I need to mention it before because some of you may need to be leaving here quickly, but it is handy to have a second outer cylinder so that when you bring your cylinder in and precipitation is still falling, that you can replace it with a clean, dry cylinder so you can start collecting the next day's worth of precipitation, and you can proceed to at your leisure do the melting and measurement required. In this situation, you'd be reporting 0 for your new snow because this is not snow, this is rain. You report 0 for snow, but you would melt its water content and report that as the precipitation amount, and then you would report its depth of ice on the ground would be a part of the total depth of snow and ice on the ground. And in your comments, it is ideal to report the radial thickness, and that's in the training slideshow about freezing rain, the radial thickness of ice that's collecting on above ground surfaces and that depth on the ground. We could do a whole training session just on that. We don't have time, so I'll just refer you to other items. And now as we end, I want to just give you a quick refresher reminder of what's on the form and what goes where. The first, where you normally report rain, that's where the rain and melted snow to the nearest 1/100th of an inch goes. That's the gauge catch, unless you found that your core sample was more representative, at which time you replace that core amount into the gauge amount and replace the gauge amount into your comments. Hope that makes sense. That's where the new snowfall goes, the amount that fell in the last 24 hours, ideally the max accumulation prior to melting and settling if you have that luxury. That's where the core sample of the new snow goes. That's where the total depth of both new and old snow and ice go, and that's where the last one is where the snow water equivalent, SWE, of the total depth on the ground goes, that are so important for hydrologic purposes, for engineering purposes, and a variety of others. 2 other points before we call it a day, and thanks again for hanging in there, covering a lot of territory today, but there is no zero like a snow zero. Just like precipitation, we want to know when it doesn't precipitate. So when you did not get snow and it's wintertime and the area around you could have had snow, please replace the NA with a 0. Likewise for the core sample, likewise for the total depth of snow in the ground, so that we know that you don't have snow. Often we have to guess that, and we'd rather just know. So thank you, and it only takes about 3 seconds to hit 0 and then tab to the next field, 0, tab to the next field, 0. It doesn't take long to make that entry. And if you had no snow but you still have snow on the ground, put those zeros in for new snow, but then go ahead and put in your total depth and your snow water equivalent SWE. And if you didn't, just leave the NAs in there and we'll all be happy, and we'll understand you don't always have time. I did want to bring to your attention that we have additional training online. We will be updating on the main website the training slideshow with the version of the show. Well, there's several different slideshows, but we have one for in-depth snow measurement. We have one for general purposes that includes rain and how to set up gauges, etc. Then we have the ice accretion for dealing with freezing rain, and then we have the tips on how to measure snow by using a scale instead of having to melt it. And by the way, we will be offering via weatheryourway.com, one of the CoCoRaHS online vendors, not a part of us, but companies that work with very favorable prices for CoCoRaHS volunteers, and they'll be selling a low-cost but good quality scale that we can use that costs about the same amount as a gauge, somewhere in that $25 to $30 range. But some of you already have them in your kitchen, so use that if you can. So thank you for hanging in there, Noah. Is there any more questions? I know we've used up a little too much time here.
Great. Well, thanks a lot, Nolan. I do want to just let everyone know, if you don't want to stick around, we're going to ask 2 more questions very briefly, but if you don't want to stick around, as you do exit the webinar, we have a very brief survey that we would ask you kindly to fill out. So it's very brief, and as you exit, it should just pop right up, and it should take you no more than 2 minutes to fill that out. So we would really appreciate that. Nolan, one question that came up that I want you to address is there's some observers out there who are just dying to be a part of CoCoRaHS, but unfortunately have an automated gauge instead of a manual gauge. Can you just speak very briefly to why an automated gauge may not be as accurate as the manual CoCoRaHS gauge, please?
I sure will, and this comes as a surprise to a lot of people, but it's not a surprise when you've been in our field for a long time. It doesn't matter whether it's a National Weather Service automated gauge or a home-owned automated gauge. When it comes to measurement of precipitation, automation has not perfected the measurement of precipitation, especially frozen precipitation. Yes, you can even get automated rain gauges that have heaters in them to melt the precipitation as it falls before it goes into the little tipping mechanism. But what we have found time after time is those heaters tend to evaporate the precipitation, some fraction of it, so that by the time you're down to cold snows falling at 15 degrees or colder, almost all the snow evaporates with hardly any of the water content being measured. National Weather Service really appreciates CoCoRaHS. Many other entities really appreciate CoCoRaHS because of the fact that we've stuck with a reliable manual gauge to give a standard baseline. The automated gauges are less consistent gauge to gauge, and again, do not perform well with winter precipitation. So we have stuck, some people think we're sort of hard-nosed about this, but the niche that has made CoCoRaHS really particularly important and special nationally is that we have stuck with a consistent gauge that overcomes some of the inconsistencies that you see with automated equipment. I love automated gauges. We have our own, but they are not the best for climate quality, historic, long-term, consistent measurements of the hardest measurement element to observe consistently, and that's winter precipitation.
Great, thanks, Nolan. And the final question that is on, I'm sure, everyone's mind here is if you have any farm story to update us on any chickens or geese or dogs.
I'm happy to report things are quite peaceful on the farm. We've been melting snow a little bit. The corral's still pretty muddy. Cleaning up after the horses hasn't been too bad, but we're still waiting for the chickens to overcome their little molting period. We haven't had an egg for about a month. We're expecting any day now that they'll start laying again, even though we're near winter solstice.
Great. Well, thanks a lot, Nolan. We appreciate that. I know that was my most important question for you there. So again, we thank everyone for attending the webinar today. And as you exit, again, to remind you of the survey that will pop up, very brief, just a couple of questions and just a couple of minutes of your time. So thank you again to everyone. We did record this, so we will post a version of this to the website once we have it rendered and available. So thank you again to everyone, and have a great Christmas.
Thanks so much, everybody.